On the 5th of November 1977, NASA was about to embark on their most successful mission of its existence. The Voyager 1 space probe was launched into space by the Titan IIIe rocket, ironically 2 months after its twin, the Voyager 2. The probe's objectives included flybys of Jupiter, Saturn, and Saturn's largest moon, Titan. While the spacecraft course could have been altered to include a Pluto encounter by foregoing the Titan flyby, exploration of the moon, which was known to have a substantial atmosphere, took priority. Voyager 1 studied the weather, magnetic fields, and rings of the two planets, and was the first probe to provide detailed images of their moons. After completing its primary missions, with the flyby of Saturn on November 12, 1980, Voyager 1 became the third of 5 artificial objects to achieve the escape velocity required to leave the solar system. On August 25, 2012, Voyager 1 became the first spacecraft to cross the heliopause and enter interstellar medium. The Sun is the star at the center of the solar system. It is nearly a perfect sphere of hot plasma, with internal convective motion that generates a magnetic field via a dynamo process. It is by far the most important source of energy for the life on Earth. Its diameter is about 1.39 million kilometers, or 864,000 miles, or 909 times that of Earth, and its mass is about 330,000 times that of Earth. It accounts for 99.86% of the total mass of the solar system. Roughly 3/4 of the Sun's mass consists of hydrogen, 73%, the rest is mostly helium, 25%, with much smaller quantities of heavier elements including oxygen, carbon, neon, and iron. The Sun is a G-type main sequence star. Based on its spectral class, as such, it is informally and not completely accurately referred to as a yellow dwarf. Its light is closer to white than yellow. It formed approximately 4.6 billion years ago from the gravitational collapse of matter within the regional large molecular cloud. Most of this matter gathered in the center, whereas the rest flattened into an orbiting disk that became the solar system. The central mass became so hot and dense that it eventually initiated a nuclear fusion at its core. It is thought that almost all stars form by this process. The Sun is roughly middle-aged. It has not changed dramatically for more than 4 billion years, and will remain fairly stable for more than another 5 billion years. It currently fuses about 600 million tons of hydrogen into helium every second, converting 4 million tons of matter into energy every second as a result. This energy, which can take between 10,000 to 170,000 years to escape from its core, is the source of the Sun's light and heat. It is calculated that the Sun will become sufficiently large enough to engulf the current orbit of Mercury and Venus and render Earth uninhabitable after this. It will shed its outer layers and become a dense type of cooling star known as a white dwarf, and no longer produce energy by fusion, but still glow and give off heat from its previous fusion. Jupiter is the 5th planet from the Sun and the largest in the solar system. It is a giant planet with a mass 1,000 that of the Sun, but 2.5 times that of all the other planets in the solar system combined. Jupiter and Saturn are gas giants. The other 2 giant planets, Uranus and Neptune, are ice giants. Jupiter has been known to astronomers since antiquity. It is named after the Roman god Jupiter. When viewed from Earth, Jupiter can reach an apparent magnitude of -2.94, bright enough for its reflected light to cast shadows, and making it on average the 3rd brightest natural object in the night sky after the Moon and Venus. Jupiter is primarily composed of hydrogen, with 1/4 of its mass being helium, though helium comprises only about 1/10 of the number of molecules. It may also have a rocky core of heavier elements, but like the other giant planets, Jupiter lacks a well-defined solid surface. Because of its rapid rotation, the planet's shape is that of an oblate spheroid. I completely butchered that, but we're just gonna keep going. it has a slight but noticeable bulge around the equator. The outer atmosphere is visibly segregated into several bands of different latitudes, resulting in turbulence and storms along their interacting boundaries. A prominent result is the Great Red Spot, a giant storm that is known to have existed since at least the 17th century when it was first seen by telescope. Surrounding Jupiter is a fair planetary ring system and a powerful magnetosphere. Jupiter has 79 known moons, including the 4 large Galilean moons discovered by Galileo Galilei in 1610. Ganymede, the largest of these, has a diameter greater than the planet Mercury, and Europa, which is believed to contain a large water ocean beneath its icy crust. The 2 moons of Mars, Phobos and Deimos, are much smaller than our moon, greatly reducing the frequency of solar eclipses on that planet. Neither moon's apparent diameter is large enough to cover the disk of the sun, and therefore they are annular solar eclipses and can also be considered transits. And this is what a solar eclipse looks like on the surface of Mars. Quite beautiful, isn't it? Alpha Centauri is the closest star system and closest planetary system to the solar system at 4.37 light years from the sun. That means that even if we could travel at the speed of light, it would still take 4 years to reach it. It is a triple star system consisting of 3 stars, A Centauri A Centauri B, A Centauri C. Alpha Centauri A and B are sun-like stars, class G and K, and together they form a binary star Alpha Centauri AB. To the naked eye, the 2 main components appear to be a single star with an apparent magnitude of -0.27, forming the brightest star in the southern constellation of Centaurus and the 3rd brightest in the night sky, outshone only by Sirius and Canopus. Alpha Centauri A has 1.1 times the mass and 1.519 times the luminosity of the sun, while Alpha Centauri B is much smaller and cooler at 0.907 times the sun's mass and 0.44 times its luminosity. The pair orbits a common center with an orbital period of 79.91 years. Their elliptical orbit is eccentric, so that the distance between A and B varies from 35.6 astronomical units, or about the distance between Pluto and the Sun to that between Saturn and the Sun. Alpha Centauri C, or Proxima Centauri, is a small and faint red dwarf. Though not visible to the naked eye, Proxima Centauri is the closest star to the Sun, set at a distance of 4.24 light years from the Sun, slightly closer than Alpha Centauri AB. Currently, the distance between Proxima Centauri and Alpha Centauri AB is about 13,000 astronomical units, or 0.21 light years, equivalent to about 430 times the radius of Neptune's orbit. Proxima Centauri B is an Earth-sized exoplanet in the habitable zone of Proxima Centauri. It was discovered in 2016.